Let's look at question 11. Okay, 11, they say use of data booklet is relevant. In fact, this question is linked to transition metals, right? So you notice all these are like transition metals, yeah? Okay, so which metal ion can be used as a suitable catalyst for this reaction? So we have to break this overall equation to two half equation, right? So I minus actually is going to react with S2O8 minus, okay? And you can calculate the E cell here. E cell here, actually, you think about it, this is oxidation, this is reduction, and E cell is 2.01 minus 0.54 is actually greater than 0. So this reaction is actually very feasible. Okay, but they want which one of them can actually act as a catalyst. Okay, so how you do it is this. Okay, so if you pick copper 2 plus, so I'm going to choose. So this, you must understand that everything here in the aqueous form. So whatever catalyst we use must be what I call a homogeneous catalyst, right? All these ions, it must be in the same phase as the reactants, right? So since the reactants are all aqueous, the catalysts here, these homogeneous catalysts must also be in the aqueous form. So I've chosen this equation, and you can see that this is aqueous and this is aqueous also, right? So I didn't choose the one that give you copper metal, Cu, like Cu2 plus becomes Cu. I chose the one that becomes Cu plus, all right? So it must be, both sides must be aqueous, right? Okay, let's see how it works. So if I use copper 2 plus, okay, do with me, yeah? So if I use copper 2 plus as a catalyst, copper 2 plus will be actually reduced, all right? Copper 2 plus will be reduced, all right? And what happens is I minus will be oxidized. Okay, I minus will be oxidized. So you calculate your E cell, right? This is my E cathode, all right? And you take this as an E anode. You'll notice that the E cell will be negative, which means the reaction cannot even take place, all right? It cannot even react. So I'm going to say this is definitely 100% wrong. Okay, let's try the next one. Okay, let's try the next one. So if I use cobalt 3 plus, they ask for cobalt 2 plus. So if I use cobalt 2 plus, check, if I use cobalt 2 plus, cobalt 2 plus will actually react with S2O8 minus first, right? So cobalt 2 plus will undergo oxidation and S2O8 will undergo reduction. Can you see that? And what is my E cell? Okay, this is my E cathode and this is my E anode, right? And the E cell, you realize that it will be positive. So that can take place, right? That can take place. And when that happens, okay, you're going to get cobalt 3 plus, all right? All right, once you get cobalt 3 plus. Okay, the cobalt 3 plus that is being formed is going to react further with I minus. Okay, it's going to react I minus. Can you see that? So what is really happening is something like this. So cobalt 2 plus, right, is actually reacting with S2O8. Okay, I'm not going to balance it, but I'll just give you the idea. It will react to give you cobalt 3 plus and SO4 minus, can? All right. So after that, the cobalt 3 plus will then react with the I minus, and the I minus will become I2. All right, and the cobalt 3 plus will go back to cobalt 2 plus. All right, and then the cycle repeats itself. Okay, so when cobalt 3 plus we have I minus, right? What's the E cell? You calculate E cell. E cell should be 1 point. This one now will undergo what? Undergo reduction. So it's actually 1.89, the E cathode, minus 0.54. So this is actually positive. Okay, and the first one just now we did. Okay, it's actually the E cell for this one was actually 2.01 minus 1.89, which is also positive. Okay, so which means cobalt 2 plus is a suitable catalyst, right? So it's actually a suitable catalyst. Okay, so actually the trick is this. There's a trick to, or there's a shortcut to doing a question like that. So what you need to do is you take this equation, break it up into two half equation, as you can see from here, 1 and 2. Show the two half equation, which you actually can get from your data booklet. And how do you find out whether a catalyst is suitable or not? All right, whether it can be a homogeneous catalyst. So the thing is, you just have to look out for one whereby the value like this, it must lie somewhere in between these two values. Okay, so if it does lie somewhere in between, it will definitely function as a catalyst. As you can see, we did calculation and it showed that it's actually possible. So if you're going to look at the next few, okay, look at this. This is 1.54, right, for manganese, right? Manganese 2 plus, right? So this is 1.54, and you notice 1.54 is actually somewhere in between, right? Can you see that? So which means this can actually also function as a catalyst. So if you look at V2 plus, okay, but make sure you pick those that are both equals, both on both sides are equals. So V2 plus and V3 plus, okay, V2 plus, V3 plus, and look at the value. This value doesn't lie somewhere in between, which means it's not going to work. All right, so the answer is going to be only 2 and 3. All right, so the answer is actually B.